These are your Integrated Math 2, Module 4, Topic 1, Lesson 4 notes. This is video 1 of 3. The learning targets on this video are I can factor a quadratic trinomial, and 2 is I can factor using the difference of squares pattern we looked at in class. Write that down. I'm going to scroll here, so pause the video if you need to. All right. Factor, here's our problem. We're going to factor x squared plus 10x plus 16. This is an algebraic expression. It's a quadratic expression. So first thing, we know that a equals 1. The coefficient of x squared is 1. B equals 10. And C is 16. All right? So we're going to create a generic rectangle. And I'm going to put the ax squared term in the upper left box. So I'm going to put 1x squared. I'm going to put the constant, the number, in the lower right box, which is going to be the 16. And now these two boxes have to add up to be 10x, right? But there's lots of ways you can break up 10x. So to help us do this so we can factor it quickly, we're going to use the diamond. And the way the diamond works is I put AC on top, so AC means 1 times 16. And I put the B value on the bottom, so my B value is 10. And so now we need two numbers that multiply together to give you 16 and add to 10. So you think of your factors of 16, 1 and 16, 2 and 8, 4 and 4. All right, out of those combinations, which ones work? That's right, 2 and 8 work, right? 2 times 8 is 16, 2 plus 8 is 10. So that tells us the x's. One box is going to be 8x, one box is going to be 2x. I don't care which box you put them in. It doesn't matter, you'll get to the same answer. So I'm going to put 8x here, and I'm going to put 2x here. All right, now we're ready to begin factoring. We're going to start here. And this is important. We need to pull out the greatest common factor going across. So between x squared and 8x, the GCF is 1x. So I pull out an x. Now it's just multiplication, right? X times what gets you x squared? X. X times 8 equals 8x. X times what equals 2x? Well, that's 2. And then double check, is 2 times 8 16? Yes, it is. So now our factor form becomes the outside part. X plus 2 is one factor, multiplied by the other factor, which is going to be x plus 8. Okay? If I multiply this, I get back to standard form for that quadratic and get expression at this point. All right? Let's look at another example. Let's look when the a value is not 1. So we have 6x squared plus x minus 35. This looks like a beast. So we set up our generic rectangle. I want to put the 6x squared up here, upper left corner, negative 35, lower right corner, and now I got to figure out how I'm going to break up the two boxes to give me just 1x. All right. Well, we're going to do our diamond. Ooh. 6 times negative 35 is negative 210. Hope I did that right in my head. All right, and the B value is 1. All right, so I need two numbers that multiply to give me 210, negative 210, and add to 1. All right, so we got to start brainstorming here. Our factors of 210. So 1 and 210, 2 and 105, 3 and 70, 4 doesn't work, 5 should work, 5 and 42, 6 and 35, all right, I used that one, 7 and 30, Okay, so far I'm way far apart, right? You gotta get a difference of only 1. Does 8 go in there? No. 9? I don't think so. 10 and 21? No. How about 14 and 15? Right? 14 times 15 is 210. All right. That one's going to work because I know one's a positive and one's a negative. And this is hard as it gets right here. I made a hard one here. So how am I going to get positive 1 when I add? I want to have it be the positive 15 and the negative 14. So 15 times negative 14 is negative 210. 15 plus negative 14 is positive 1. So one of these boxes is 15x, one's negative 14x. Let's go ahead and make this 15x, and we'll make this negative 14x. All right, so now we gotta be real careful here with our GCF. GCF of 6x squared and 15x, I can pull out a 3 and an x. All right, so pull out 3x. 3x times what? 6x squared? 2x. 3x times what's 15x? That's going to be 5. 2x times what is negative 14x? Well, that's going to be negative 7, right? And then negative 7 times 5 is negative 35. That is true. So my factored form of this becomes 3x minus 7 multiplied by 2x plus 5. So if I multiply this, I get back to here. All right? So that's factoring quadratic trinomials. Please note that the generic rectangle and the diamond, this is only for quadratic trinomials. Some of you have been trying to use this for other things in class. So only for the quadratic trinomial. One other factoring pattern we discovered the other day is this idea of difference of two squares. All right, so if we have a squared minus b squared, so difference, subtraction, two perfect squares, it comes out to be just a minus b times a plus b. All right, so let's look at a couple examples. We want to factor x squared minus 81. Well, the square root of x squared is just x. That's a perfect square, so I'm going to write it as x squared. And 81 is a perfect square. The square root of 81 is 9. So it's x minus 9 squared. All right, so that's this part. So I use these terms, and it's going to be like this with minus and this with plus. So this factored form is going to be x minus 9 times x plus 9. All right, one more. Hard one here. 16x squared minus 121. Perfect square, right? If I took the square root of this, I'd have 4x. I'm going to write this as 4x squared minus, square root of 121 is 11. So minus 11 squared. Difference of two squares. So boom, what's my answer? That's right. It's 4x minus 11 multiplied by 4x plus 11. All right. One last thing I want to mention. When we factor, always look for greatest common factor first. No matter you're doing one like this, or we're doing one of these, 6x squared plus x minus 35, we should look for a common factor first, because sometimes we can make an easier problem. And these examples, I didn't have one in there. But we should always look for a greatest common factor. All right? Thanks for taking your notes.